Hello, everybody. I hope you are having an exciting weekend or a good, happy Monday. We can make it till the end of this trip, this little bit of trip before our vacation. If you're already on vacation, I think you're awesome for doing a little bit of math homework while you're at the beach. Good for you. Just make sure that you're done with these lessons and you're caught up with the material before we get back to school on January 2. Today we are going to be given some quadratic equations, and so given the graph, we need to write an equation, graph to equation. I kind of hid the instructions here. Let's look at this problem number one. If they gave you a graph like this and they told you to write an equation, would it make more sense to start off using a vertex form or factored form? And in this particular case, because they gave us the x-intercepts, we want to go factored form. And I know that the way the homework goes on Monday, they're also going to ask for general form, but I always call it standard form. But for today's notes, we'll call it general, I suppose, and we'll go factored form and general form. Number one, I always start off by writing out the factored form equation, just to remind me of what the equation is. So it's y equals a times x minus c1 times x minus c2, where c1 and c2 are the x-intercepts. So if I plugged in the x-intercepts, in this next step, I'm going to plug the x-intercepts into the equation, and I'm also going to plug 0, -8 into there. So this is my C1, this is my C2, this is my X, this is my Y. So Y is -8, A, X is 0, minus C1, which is -1. Be careful with that. And then this X is 0 minus C2, which is 4. Okay, now we want to algebraically solve for A. Here I have a -8, here I have an A. -1, that's a positive 1. 0 times -4 is -4. So I have -8 equals -4A, and when I divide both sides by -2 or -4, I get an answer of 2. -2, no, I divide by -4, so I got an answer of positive 2. So then you rewrite your equation, your answer with the C1s and the A, or the C1, the C2, and the A. So I have 2 times X, the -1, which was the positive 1, because this says minus, you want to put a +1, and X minus 4. That is my factored form equation. Then to get to general form, I'm going to need to multiply this out and then multiply by 2. X times x is x squared. The outers is -4x. The inners is plus x. -4x plus x is -3x minus 4. And if I distribute my 2, I get 2x squared minus 6x minus 8. And then circle the answers we're looking for, which in this case is your factored form and your general form answers, or standard form, depending on what you call it. All right, that's it for example number 1. Example number 2 is very darn similar, except it's an upside down one, so your A is probably going to work out, well, it will work out to be negative unless you've made a mistake. Pause the video, try out number 2 on your own, and then once you have an answer for number 2, then replay the video, maybe in double speed or triple speed or something, and or if you just jump forward a minute, it'll probably take me about a minute to solve this problem. So anyway, pause it and then play it, see the solution. Go. Y equals A times x minus C1, x minus C2. Y is -21. A. The x is 6. So 6 plus 1 and 6 minus 5. -21 equals A times 7 times 1, which would give me a 7A. When I divide by 7, I get -3. So my final answer for factored form is -3 x plus 1 and x minus 5. That's my factored form equation. And now I work into standard form. So negative 3 times x squared minus 4x minus 5. Final answer, negative 3x squared plus 12x plus 15. And at the beginning of the problem, I said a should be negative or a will be negative. Oh, look, a is negative. So that's a little redundancy you can do in these problems. If you know the answer is supposed to be negative, but you get a positive answer, or vice versa, you probably made a mistake. All right, the next couple examples. Check out these graphs. What part of the graph are they giving us? That'll let us know which equation we're supposed to use. Seems that they're giving us the vertex. And because they're giving us the vertex, we're going to want to do these ones in vertex and then also general forms. So I first like to write the equation out. So y equals a times x minus h quantity squared plus k. This is my h, this is my k because it's the vertex. This is just some random other point, so that's my x and my y. So plug it all in. Negative 21 equals a times, here comes the x, which is 6, minus the h, 4, quantity squared. The k is negative 1, so minus 1. Algebraically, we now need to solve for a. So negative 21 equals a times, let's see, 6 minus 2, or 6 minus 4 is 2. 2 squared is 4. So a times 4 minus 1. I really should have written 4a here. That's not very good math. But my next step would be to add 1 to both sides, so I'd get negative 20 equals that 4a that I mentioned a minute ago. Divide both sides by 4, and a is negative 5. So your final vertex form equation is y equals negative 5 times x minus 4 quantity squared minus 1. And now we also need to work towards general form. And to do that, I would have negative 5. This x minus 4 is squared, so you might want to... Some people can go ahead and multiply this out in their head, and if they can, x squared minus 8x plus 16. You don't need to show this step in the middle. But if you're one of those people that really needs to see it and FOIL it out step by step, you should. X minus 4 times x minus 4, that is x squared, negative 4x. So minus 8x plus 16 minus 1. Distribute the negative 5 into the parentheses, but don't include this negative 1 in that. So negative 5x squared plus 40x minus 80 minus 1, which then becomes negative 5x squared plus 40x minus 81. And that is now in standard form, or general form, depending on what you call it. One more example, and then same thing. I want you to look at this problem. I want you to try it out on your own, see if you can get the right answer, pause the video, and then once you have an answer, replay the video, make sure that you did it right. So pause now. Here comes the solution in an Elliott sip of water. Here we go. Y equals a times x minus h quantity squared plus k. This is my x and my y, this is my h and my k. So y becomes 20, a becomes 2, h is a plus 3, and k is a 5. 3 plus 2, 2 plus 3, that's 5. 5 squared is 25, so this is 25a plus 5. Subtract 5 from both sides, so 15 equals 25a. Divide both sides by 25, and a ends up equaling 3 over 5. So y equals 3 over 5 times x plus 3 squared plus 5. Oops. Sorry about that, folks. That is my final vertex form answer. All right, now I can multiply it out to work into standard form the same way I did this one. You can use it side by side to give you reference. So 3/5. Now, I personally can do this. X squared plus 6x plus 9. 3 plus 3 is 6. 3 times 3 is 9. Same thing. -4 plus -4 is -8. -4 times -4 is positive 16. That's how I do it. Plus 5. Y equals 3/5 x squared plus 18/5 x plus 27/5 plus. I know that this 5 is going to need to be added to 27/5, so I'm just going to immediately get this a common denominator of 5, which would be 25/5. Final answer, 3/5 x squared plus 18/5 x plus 52/5, the number of cards in a deck, 52. Don't forget to circle those answers, so that, because this answer is kind of hidden in the middle, so it's really important to circle it. Standard form answer, or general form, depending on what they're calling it that day at the end. Don't forget about the y equals. All right, everybody, so that was 4 examples of getting equations, giving a graph, a parabolic graph, given either the x-intercepts or the vertex, and then coming up with some equations for it. Yep. I only have one more thing to show you before Christmas break, or excuse me, holiday break, and that is completing the square, and that's what I'm going to show you next time on Monday. Until then, have a great day, and I will see you later. Bye-bye.